I know the questions are going to come, from all directions.
So, am I starting now?
Yes, you are.
Ekason ei oremini Nigeria. Inumi dun lativa peli in loni. Orokomini George Lungu. Alwada mini, alwada nimi. Moma en fi Excel Animation Games atiawon kan miron. Ki adei pelorifon Anthony Joshua. All right, so my name is George Lungu, and I will be your host today. I will be your presenter. So what I managed to work out with Mike is a little introduction in Nigerian. Hello, my friends from Nigeria. I'm happy to be with you today. My name is George Lungu. I'm a joker, which means an Excel joker. So I use Excel to create animation, games, and other fun stuff. And this is their local hero, the boxer, Anthony Joshua.
So you might want to maybe also share your screen.
Yes. I'm sorry. Yeah. So we had a little technical glitch here, and I did not show you my stuff. So this is what I was trying to pronounce. Okay.
Okay, it's not a screen, huh?
This is the English version.
I think, have you been able to get hold of that share button? That rectangle with an arrow pointing through the center?
So it's not showing?
Not yet.
Not yet. Why? Let me see. No, yes.
Oh, yes. Okay. No, not yet.
No, this is it.
Not this one. So it's the screen one. If you stop the sharing, then this time around you pick the screen one. So that one shows as it should be.
Oh, this one. No. Sorry.
Awesome. Yes.
This is it.
Yeah. So now I'm seeing myself, but I'm sure when you. Oh, yeah. Yes.
Okay. So I'm gonna start again. Okay.
Awesome.
So we created a little introduction. Okay. In Nigerian, which has a name, but I forgot the name of the dialect.
It's Yoruba.
Ekason ei ore mini Nigeria. Inomidun latiwa peli in loni. Okuro mini George Lungu. Alawadanimi moma en fi Excel se animation games atiawon kan miron.
Yeah.
Ki adei pelorifon Anthony Joshua.
Yes.
So that's their local hero, and I'm a fan of the local hero.
Yeah.
So I'm ready for the interview, Michael.
Okay, awesome. So the questions are going to start normally from, we want to even hear your journey, your let me try and make something. I'm seeing myself and it's you we want to see, so I want to make you spotlight so that we see you. Okay, great. So we're going to start first of all with you telling us about your journey, how you've gone from I don't know how far back you want to go. Maybe even tell us as far back as your introduction. You mentioned you're originally from Romania, and then your journey to US, and then your engineering feats, and then why that special interest in Excel, and you using them for things I don't see any other person use Excel for. That's something I'm really interested in getting to know about. So yes.
Okay, so let me start. I will talk for a few minutes, just general. I came here in, I believe, 93, and I was completely computer illiterate. Okay, so I didn't know how to use. We had the Excel Microsoft Excel, but I was not sure how to use it. So my second year, I believe, at the beginning, I started using, and it was fairly easy. And I used it in the lab, like for doing the required lab work, just you know, regular charting and basic stuff. We had tables with data, and then we had charting and a little bit of, you know, Microsoft Word, a little bit of Excel. And then I also used this when I did my thesis, and then in 2000, I believe, 4, it was right during the market surge, when I was trying to figure out if I can trade the market looking at numbers, at data rather than feelings, you know. And I asked my girlfriend, who now is my wife, but to make me some basic macros. One was how to enumerate, how to count up, which is what in electronics we call a counter or a clock. So having a cell, have a little button, click start, and in a cell I had 1, 2, 3, 4, counting up by 1. And the other one was, again, the start and the stop macro, how to start a macro, how to stop a macro. And then I play with that a lot. Essentially, for maybe a year, I try to find ways to trade the market. I wasn't very successful because always, you know, it's relatively easy to come up with an algorithm. It's very, very hard to stick with it because your feelings, you know, when you have money in the game, you let your feelings overrule you. And I was also part of a group of traders, I believe, within TradeStation, and essentially I was making public everything I had, and people were, of course, taking it. So whatever I had working, I couldn't have the strength to keep it for myself. And before you knew it. So essentially my real journey with Excel. So this was the first contact, the first real contact, when my wife showed me how to create a simple macro and how to count up. But the real let's say professional Excel activity started in 2007. It was in I would say May, June. I moved to a company called Vitesse, which means speed in French, Vitesse Semiconductor. And we were doing something called adaptive equalizers, which are nothing more than adaptive filters. These are essentially filters that adjust their own parameters. In telecommunications, for very, very high speed, we have a transmitter, usually either very far or through a long cable, and a receiver at the other end, and the signal after, which is a digital signal, after this cable becomes very, very corrupt. It doesn't, is not a digital signal anymore. So you cut me. Okay, it's okay, it's okay. Just let's make sure I'm fine. So these filters are, at that time I thought it was a very, very difficult subject. I couldn't understand it, and I started printing all these papers, essentially, literally hundreds of papers. And since I just moved to a new town for a new job, essentially my mattress where I was sleeping on the floor. We were in a provisional setting, in a temporary housing, was buried in this paper, and I was reading them and reading them. And Still don't understand them, but after a while, you know, the more you read, the more diagrams you see, something in your subconscious start, you know, building, and you start understanding a little bit of things. Then I was talking to my boss, and he was explaining me. Then I realized he didn't understand himself, the filters. He was just doing, you know, blocks. He was specialized in a few blocks. But to make a long story short, I tried in Excel. I said, you know, a few things start clicking in my mind. So I need to, you know, create a very, very simple, try to validate a few concepts. And when I was at home after work, I picked up this little nugget that I was reading, or I tried at work, and put them in Excel and made a very, very, very basic model. It wasn't anything animated, it wasn't, but I could synthesize some of this knowledge and make it work on a very, very basic level, like a little slice this day. Then the following day I was playing with the slice, usually maybe 2-3 days. Then let's say the third, the fourth day, I was putting another little slice, and then that worked, and I understood it. I understood much more from this than reading papers. I think reading papers was good. It kind of made me my initial, you know, mind. And then, hello, and then after a month, about a month, I had a model that was working without automatic algorithm to create these parameters for the filter.
Whoa.
And but when I brought it to work, it was beyond. We had one person who understood these filters really. Most of the people were doing like little slices.
Okay.
So this part really, when I brought it to work and I showed the guys there, my colleagues, including my boss, it was really very, very good, even though I didn't have the automatic adaptation algorithm to find these parameters of the filter. I could correct the signal. So I took a, you know, very, very distorted garbage signal and turn it into good signal using Excel. Just clicking on the buttons. You know, I had these spin buttons, and I can show you on my site.
Okay.
If Mike is nice to show us the my website.
Should I share from my side, or do you want to share?
Actually, I can. Do you think I am?
Yeah, you can. So
I am on now. So let me show you.
Okay, so if you go there, we'll be seeing. Awesome. Yes, you are.
Okay, so now you see it, and this is my site, my website, and it is loading a little bit slow. Let me see.
Audience, all of what you are seeing here is Excel. You know, all those things you're seeing.
Right, those are Excel. I'm trying to show you this particular model. Okay, here it is. I'm gonna zoom in. Okay, and what you see, this is low resolution, but right here to the right is the model I was telling you. So this is adaptive filter, adaptive equalizer, and God, it's changing very fast, but essentially this is the schematic, the diagram right here. Okay. And on top with the blue, you have the bad signal, and on the bottom with green, you have the good signal after the filter. And, you know, not to tell you more than this, but when people saw this, and after a month, I had my Excel sheet managing to so-called adapt or correct this signal. And in another month, I had an algorithm, an automatic algorithm that I made just thinking of the problem and playing with Excel. So, and I don't want to tell you more, but in a month I was out with no jobs. Essentially, this triggered kind of an envy, you know, there were people there who were for over 10 years, 10, 15 years, and they didn't understand the filters because all they did, they read the papers. rather than trying hands-on to build it like I did it in Excel, they were just reading papers and regurgitating formulas like I was doing for the first few months. So when I start using Excel, every day I got a little bit closer to solving the problem. In a month I had a filter, in 2 months I had a filter and an algorithm. So that convinced me that Excel is really gold, because what they were doing for many months, we were meeting at restaurants, at lunch with the vendors, trying to buy software to simulate these filters and design it. And there's the guy who is new, who doesn't know much, you know, who comes from a different company and does this in Excel. So this was an eye-opener for me. And after this, I went to work as a consultant, so as a contractor to a company called Freescale. Freescale Semiconductor, which is of Motorola, so formerly Motorola. And what they were doing there is they were doing accelerometers and gyroscopes, right? For automotive, for cars, you know, deploying airbags or stability control. And when I got there, essentially, I don't want to say I lied, but I exaggerated what I knew. They were using MATLAB, so I said, I know MATLAB, okay? And I didn't really know MATLAB, but going there and I saw what they have in MATLAB, and always there's a schematic like what you see right here. You see these blocks. So this was done in MATLAB, and they told me, George, you're gonna need this, I don't know, 4 months to begin to understand these things. And I was looking and I said, I didn't say I was thinking, I don't think so. So I went home and I spent 2 weeks, 12 days actually, looking very hard and trying to replicate in Excel what they did in MATLAB, seeing these block diagrams like you have here, block diagram. So in about 12 days, spending probably between 4 to 6 hours very late at night, wow, I managed to come up with a model in Excel. This time I knew much more Excel than when I went to Vitesse half a year before. And I made this nice animated model that was solving several problems. Essentially, these accelerometers and gyroscopes need to be certified, go through a battery of tests, several different tests. So my model in Excel, in the old Excel, was running, I believe, about 22 seconds. In 22 seconds, whoa, was doing what they were doing using software and also operator, you know, like reloading and redefining tests, going through a battery of tests in, I forgot, maybe 40 minutes. So really my thing, because it was all automated in Excel, was running almost 100% faster in a program that is free. Excel, I mean free, relatively free.
Yeah.
And I got a lot of, especially the chief engineer got very, how do you say, aggressive. You know, he came to me at lunch and I'm gonna kill you. You know, so I say, why? I say, because you stole my model. I say, no, I didn't steal anything. I just did it in Excel. And not useless to say, in probably about 10 days I was out too. So then I started, I said, you know what, don't mix this with work, because you discover stuff. I mean, Excel is so powerful in helping you understand problems that oftentimes you have a whole team and they don't, make progress. And Excel is so easy in Excel to really understand the problem step by step by building small slices every day. Yeah. Let's do some fun stuff. And then I start doing, Planetary Motion. Actually, that while at Freescale in Arizona.
Okay.
I made, you see this kind of stuff right here. This is a planetary model.
Yes.
These two. And again, my principle on doing this is not to just go to formula, is how much do I know about this? I know a little bit because in high school, in the 9th grade, so the junior high school, not freshman, we were doing mechanics, and I know there was a formula that shows that the attraction between two bodies is proportional to the product of their mass, reversely proportional to the square of the distance, and then there's a constant in front. So I knew that. And also I knew something that I deepened working for these guys at in Arizona, which means Newtons have 3 fundamental laws. One is action and reaction, the other one, force is equal mass times acceleration, and the third one is the third one is the first one actually, is if you don't touch an object, the object will continue to move in a straight line with the same speed, or stay on the spot. And this is valid in an inertial system of reference. But anyway, using this, I was able to, knowing the forces. So the force, you always know the forces between the two planets, because the force is determined by the attraction, the formula I told you, the product of the masses. And then using this third laws, I managed to integrate. You see, it sounds very smart, but it's not. It's very simple. If I work with anybody, I can teach him this. So essentially, knowing if this force, you can integrate, find. Actually, you can multiply by mass, find acceleration. You can integrate, find speed, and you integrate again, so double integrate and find coordinates. So here I am having this, a few very elementary and fundamental concepts from freshman in high school, from the freshman year in high school, being able to model mechanical things that I never dreamt of, and doing this in Excel. So I had a lot of fun. After that, I spent quite a few months at home doing just fun work. And this is another one. This is essentially what you see here on the top.
Okay.
Let me see. These are accelerometers, both of them. So an accelerometer essentially is a mass, so a weight tied to a heavy base. In our case, this is a car. So you have a vehicle and a little mass tied with a spring, and this is called a damper. It's essentially a strut. It dampens oscillation. So here are 2 of them in series, and depending on the deflection or departure of this mass from the equilibrium, you can determine the acceleration of the, let's say, car. You see this green rectangle. This is represents, let's say, the vehicle. Okay. And based on this deflection, you can decide to either deploy the airbag, not deploy the airbag, or you know, maybe lower the power of the, even though the driver maybe pushes the gas, when the deflection of this little mass, which is usually built very, very small in a chip, when it exceeds a certain limit, you can decide that, oh, I'm going to cut off the power from the wheel so the car doesn't get into a spin, into a skid, you know. Oh. So, okay, and I'm going to show you a few more things. This right here is a polymerization model, and essentially I did this in 2018, and even though by that time I was using VBA very sparingly. I mean, most of my models until 2018 were done in cell formulas.
Wow.
And with very little, you know, the macro I told you, the start-stop macro and the counter macro. So one that counts 1, 2, 3, 4. So I was writing many different formulas. Like, actually, let me minimize this and show you a physical file, okay? So, I invite you to go to this website, excelunusual.com, and type roller coaster and download this roller coaster. So click on either one of these two. So I typed roller coaster here in the search box. I click in one of them, and this is a video, but you can click on this Excel download little button, and they ask me, do you want to open it? Yes. If you have, then this is the old Excel. I have both of them on my computer. So the old Excel is very fast, the new Excel is slower, but it's gonna still run in the new Excel that you have, but you might have to go to enable macros. Okay, so you see this sun here? I click on it and it takes me to a little roller coaster ride, and you can just watch the screen, but you can also download it later or now, whenever you want. So here it throws you through some curves, through some turns, and then goes through a loop, through the eye of the loop. And you can see here, right here, you see all these numbers changing? You have formulas here. You see, this is a formula. So what I was doing, I had a macro. You see this index, this is the macro I was mentioning at the beginning that counts up. So let me see. You see it's counting up, 1, 2, 3, 4, up. And this little number that grows is included in some formulas. And the formulas will generate this roller coaster. So how do you generate this roller coaster? If each of these points, let's say, I believe I did something here. I cannot click on it because this is modified, but if I close this and open another sheet, okay, a little thing here. So let's say 0, 0, okay, and call this column X. I'm going to show you how to build a small, very basic model, X and Y, okay? Click on this, center everything, and let's say 1, 1 here. Take this and say insert chart, and I always like to use this scatter chart with broken lines. So let's make this format axis from -5 to 5. Michael, do you think I should waste 5-10 minutes to do this, or I should just talk?
Yeah. Yes, please do it. We are enjoying it. Well, I'm enjoying it.
Okay. So -5 to 5. Here, again, -5 to 5. And I'm more familiar with the old Excel. I use the new Excel a lot now, but I started with the old Excel. It's still a big love of mine. So, and it is so fast. You know, you can do these animations fast. In the new Excel, some of the animations don't work because they're too slow, and some of the animations do work, but they're slower. So again, from -5 to 5. So we have 1 point here. I'm gonna change the patterns here, and I'm gonna add major grid lines on vertical. Okay. So and I'm gonna drag this here, and so okay. So let me. This is very basic, but it will give you an idea. So X is on this axis, Y is on the vertical axis. 0, 0. How come I don't see it? Let me see. Because source data, because probably it's all messed up. I'm gonna delete this, remove, and add a series. And for the X values, I'm gonna highlight this all the way down. And for the Y axis, I'm gonna highlight right here, okay? Okay. And I'm gonna make the points much bigger so you can see what I'm doing here, okay? But essentially you have 0, 0, this point, 1, 1. Let's make this, let's bring this to 1, no, 2, 0, okay? 2, 0. So you see what I have here. I'm gonna increase the line thickness, make it really fat. And let's put a point right here, okay? So 2, 2, okay? 2, 2. And again, if I click on it, you see I selected a lot of points. Let's select a point here, -2, and 2. Select another point right here, so -2, -2. Change the first point to 0, -2, -2. See, I'm just, I look at the chart and see what I have here. Again, -2. And let's bring this point back a little bit where we start with, where we ended. So -2, oops. So we got a square, okay? And I want to also add, this wants to be a house, a very little house, okay? So let's add here a point. Let's say right here, okay? So 0, 4. 0, 4. So this is very important because I show you how to break this line, okay? I just move this here. So when you leave an empty space here in the table, there won't be a line. So let's put this point back here. Instead of 0, 4, let's make it, actually, let's put it right here. -3 plus 2. So -3 plus 2. Then let's put a point, let's make a point right here. So -2.4, -2.4. And a point right here. So 2, 4. And again, you can try this in the old Excel, you can even do this. Watch me. I click once, I click twice, and then drag the point. You see, it changed the data. This is a very nice functionality aspect that they canceled. I mean, they did not follow up. They did not introduce in the new Excel. I hate it, but I'm saying you can do this. I'm gonna go here, 3, 2, and also go back to the first point. So this is equal to this, and then, and again, you can go here and click once. If you click once and then double click, you can change the color. Let's say make this red, all the house, or just go to click once, wait a little bit, click twice, and then you can change the color of just that particular segment, okay? So you can use this. Another thing that you can use, you can take this, move it here, and have 2 different charts, 2 different, how do you say, series. So for this one, let's say you click and say, let's make it blue. Wait. Blue, and then right click, source data, add series. Let's call this roof. Okay, and take the X from here and the Y from here, and you have a roof. And for this roof, you can, like we did before, we flatten it. I can also build a door, a window, whatever. Another thing, it kind of preoccupied me from the beginning while I was in Arizona. When I started doing this, how can I do 3-dimensional charting? And there is a post in my blog right here. If you type 3D, means 3-dimensional, you can go, and there is right here, I believe. Let me see. I believe this one you can hit continue reading, and it shows you how to basically it's not this one, maybe this one, yes. So essentially, I realized that you don't learn anything. I mean, you don't learn anything for a long time. You don't have a deep learning if you just read formulas and try to understand the mathematical derivation. So what you need to do is, after you learn something in school, you learn some principles, try to forget, I mean, go away and then start from zero, close the door, don't read, don't watch videos, try to figure yourself out with a pen and a paper, and even better with Excel, try to figure out how did I do that? Can I remember? Can I rebuild, re-derivate this? So essentially, my problem was looking at the screen. I see something that looks like a 3-dimensional object. How is that 3-dimensional object represented on a 2-dimensional screen? Because the screen is flat. And I came up with this very, very basic model. Essentially, I'm thinking of the computer screen as a piece of glass, and I have a little gun, okay? So let me just, so if you click there.
Wow.
So here, I don't know where, oh, here is the little gun. So I have a little gun, I have the 3-dimensional object, and I shoot to the point that I'm trying to represent with the gun, and the bullet creates a little hole. How would I describe the X y coordinates on the screen, which I think they use the letter UV instead of XY. So in 3-dimensional you have X, Y, Z. In 2-dimensional you have U and V. Okay.
Yeah.
So, and I came up with a very, very basic. These are the formulas. Essentially, knowing X, Y, Z. How do you come up with this UV using very simple geometry? And again, most of the stuff you do in school, in high school, even in college, is, I wouldn't say useless, because it teaches you how to think. It exercises your mind, but you will never find it, need it in practice. But there's one thing that you always need is geometry, basic geometry, not the level they try to teach you in high school, but you always need this, like similar triangles or basic trigonometric formulas. So essentially, knowing X, Y, Z of the object, I can find UV, the 2-dimensional coordinate UV, knowing the 3-dimensional coordinate, and knowing also how far the object is from the screen, okay, which is SO, screen to object, S, screen, O, object. And also how far my eye to the screen is, so I, E to screen S. So using this, essentially you can take a lot of 3-dimensional stuff and turn it into this 3-dimensional, turn it into a 2-dimensional image. And Mike, maybe you can share these files that I gave you.
Yes, I have.
Okay, go ahead.
I have. I've shared them all: the constellation, the horse, the motor sprites, and your websites.
If you can open, if you guys receive that, can you open the file called horse?
Okay, so
let me see.
Let me direct them to this.
I believe this is it, and this is the old. This is a new Excel. So what I showed you before with the house is called wireframe. Essentially, you just represent a few vertices, a few points of the object, let's say corners, and connect them with a line, with a broken line. This is called wireframe animation, or wireframe representation of an object. Now I use two different types of animation. One is wireframe, the other one is sprites, using sprites. So sprites are essentially the little fairies, the little elves and fairies, but in animation for objects that are very far away. You don't need a 3-dimensional representation. You just use an image. Let's say you have an airplane, okay, coming to you, flying closer to you. When it's close, you need to have a 3-dimensional representation, but when it's far away, you can just use a 2-dimensional little image and show the plane as a 2-dimensional image. In this case, I have this horse that I usually go to on the internet and type horse GIF. GIF, GIF is a format of imaging that moves. A lot of memes are produced with these GIF images. So I take these GIF images, I go to Google and type break GIF images. So Google shows me a list of sites that can break that animation, that little GIF images, into individual images, because all these animations are essentially a bunch of static images. Let's say you see the horse in different positions. And what you do is you take one picture at a time and display it in a certain area of the screen where you can see it, and keep the rest of the images hidden somewhere far away. In this case, they are not hidden because I want people to see what I'm doing. So you not only bring them on the screen, but also move the image.
Wow.
So I'm going to stop this and go to Macro, Developer, Visual Basic, and boy, this is well, maybe I shouldn't get into details, because anything I do, even though I know it very well when I do it, there's something I do, and I advise you to do the same, unless you use something very often. Like let's say you're an accountant and you use pivot tables or VLOOKUP, which I never use, but let's say you need to know stuff that you use every day, especially if you have a boss, if you have to work very fast. But I never remember anything. I always have a few models lying around. I open them, I look, oh, that's how it's done. So whenever I don't use something for even a week or a few days, I forget, and I just open an old Excel file, or just go on the internet and type and try to find out how to do certain things. And I did stuff hundreds of times, the same thing. I don't have a location in my memory for this syntax. Of course, I know how to start a sub, sub and then end sub, stuff like this. And of course, I always know the loops, though I sometimes don't remember them right. So I try, it doesn't work, and then I go to Google sites, type for loop. But I always know how useful is this, how useful is that. I always know, for instance, that if you type do events, it will run the macro and display each step of the loop. So you see here a few loops. You see a do loop, you see do, that increases an index k. And then this do loop displays a certain horse image at any time, displays only one image, different image, because I name these images. Like you see, this is called horse 10. This is called horse 9. This is called horse 8. So I have from 0 to 10, 11 horses. They're all different. So this loop goes and counts up from 0 to, let me see, I think this is the loop actually. This loop is the animation loop. This loop is the, it changes the horses. And this loop, I think, moves the horses from left to right. But if you see here, this construct, I think, is called concatenation. Essentially, I act on an image called horse and then use this concatenation symbol. You can type concatenation, find out how to use it. Most people probably know already. But you can have this index, this mathematical index change from 0 to 10. And it changes the horse and puts it right here at the coordinate called left. And again, probably most people know, if you go and you have an object, let's say either this object or this object called horse 10, horse 8, the distance between this edge and the left side of the pixel is called X, and I mean horizontal coordinate, and is measured from left to right, and the distance between the top, right here, the edge of the screen, and this corner, this top border is Y. So in this case, the horses are moved one at a time, brought into the view and moved from left to right using this macro right here, this loop, this while loop. And the button itself, right, this one, okay, will start this loop, and when I click it again, there's I use a certain variable called status. It changes the status. I don't want to go into more details, but I like to have the same button starting and stopping the macro. I call this a start-stop macro. So let me go over a few things. I think Mike shared the screen. I'm sorry, the files with you.
Yes, I have.
Thank you. I'm gonna start the Christmas tree. You can go right here and start the Christmas tree model. Actually, since you guys, this is the old Excel. It runs very fast, very fast. Since you don't have this, I'm gonna open the new Excel, because that's what you have. So I'm gonna open first the Excel and open the model, this Christmas tree final is made in the old Excel, and the new Excel has a feature called compatibility mode that you can open. So what is nice about these final models that I have, like the Christmas tree, is you can use both old Excel and new Excel. So okay, I'm gonna start this. It's a little bit slower, okay? So there is a little control panel here. You can click, you see the little girls here. When Santa comes on close to them, I mean on top of them, they start jumping of joy. Okay, so click and make them disappear. Click on the dog, the witch. Click on the witch, and where is it? Oh, okay. Just make it disappear. Click on the storks. Click on Santa, the woodcutters, the little cat, and the owl. So right now you have just the tree here. I'm gonna move to the right, and what you see here, these are the sprites. Okay. You see, let me stop this because you don't see the name of the shape, so stop it now. So let's say witch template 4. This model is a little bit more complex in the sense that I use templates, and every time for each time sequence, I copy the templates I use, rename it witch. So let's say I copy witch template, because I don't want to, sometimes Excel messes up. Excel actually with the VBA is fairly safe, you know, it rarely does, it rarely makes mistakes, but sometimes it does. So I have these templates that are never touched by Excel, are never taken and moved around. every time I start a macro, it takes them, puts them in a certain designated storage area, like for the girls is here, for Santa is here, and copies a certain sprite, let's say which template 4 into which 4, and it takes that shape and puts it in a certain position with a certain orientation, with a certain rotation, and then for the next frame, using this loop, it deletes all the existing sprites on the screen and selects a different sprite of each object that I need and place it in the right position. So it's very safe. This little box here has icons for each object, and each has a certain macro. So if I go here on group, let's say this one, assign macro, and you see what it says, dogs presence. So there is a little macro inside the big VBA developer, which I bet there is one called dogs presence. So I use macros and sub macros. So big macro called, this is a little bit more complicated. I have no idea how it works now, but it's enough for me to spend, I don't know, an hour to figure out, maybe even less, to figure out everything. So, and again, an advice for you, do not memorize syntax unless you use it every day. Don't worry if you forgot. Don't feel stupid because you're not. People who are stupid are the ones who know a few tricks and memorize them and keep their mind occupied with this, you know, like a little syntax. Do not remember anything. Just remember the value of a certain, like I told you, for instance, do events help you display, update a chart or images on the screen every time a loop runs. If you don't use these do events, you're not going to see any update. You know, the macro will run, the loop will run, but the image stays fixed. So no, you know, there are maybe 3 different loops. Each has its own value. Each has its own particularities. Become how do you say, fall in love with one loop and use only or mainly that loop. If you need something that loop cannot do, then learn another one. And even that one that you use all the time, you use it for 20 years, you use it in 100 models. You don't need to remember it. Just remember, oh, there is a loop that does, it's called for loop and has these features. So whenever you start a new model, either copy from the old model or go to Google and say for loop, how does it work? You don't need to say how does it work, just say for loop VBA, for loop in VBA. And then the syntax comes up. Because you used it 1,000 times, you will kind of remember maybe to copy it creatively, you know, not, I mean, you copy it, see it works, change some parameter, works better. Always, can I make it simpler? If you look at the regular VBA code written by people and it looks very complicated, it has a lot of stuff that a lot of the real experts, you know, I'm not an Excel expert, but there are people who really know stuff like Mr. Excel or so Mr. Jelen, or there was another one I like, Tom Urtis. You know, these people are like gods. They really know their stuff. But I'm saying, if you watch their syntax is really rigorous. It has all these how do you say, option, explicit, whatever, and they declare all the variables and constants, and I don't do this. If I can write it, if I can write something that is 50 lines or 100 lines in 5 lines, I will write it in 5 lines, breaking all the rules, because my models are not for to put in a database and other people to use them, are for myself. But I'm saying there's always a middle point that you don't, if you have to declare something, declare it. If you have to use a complex structure there, you use it. But if you don't have it, don't use it. So you can always slim down your code to half without breaking too many of these rules. So don't remember anything. Don't clutter your mind with this syntax or whatever. You always, there is Google. You can use Google, and always have a few of your critical projects, like small piece that was very important. Make every month, let's say the month of January. You can call it ideas or how do you say, template. So in this case, I have a few loops, I have a few images that I move, and the next month or the next year, I open this. Oh, I got copy this snippet of code, so I don't remember, I don't clutter my mind.
Okay.
So I'm ready for some questions.
Awesome. So I know some people are already putting comments in the chat box. Someone even was saying if you can give you 2 hours. So please ask your questions. You've answered all the questions I have planned all at once.
Do I see? Can I see the chat box?
Yes, it's the okay. I can see your screen now. Great. It's that thing with the orange icon.
Oh,
yeah.
okay.
So yeah, anybody wants to ask his question, or I should start fishing through the chat box to look for what people have said? But yeah, has anybody?
So should I wait for you to ask the question, or I should answer it? Just read it from here.
Okay, maybe I will read it then, so that
okay.
stress you too much. Okay, so okay, so one question is, do you have a training that someone can have? So a lot of people are asking that, do you train? I think they want to learn from you, how you approach problem, because the way there's particularly someone who wants to apply this same concept you have explained. He's also an engineer, a civil engineer, and he's trying to adapt them to his own field. So he's asking, do you do trainings?
Okay, so very good. He said something about adapting. That's the most important thing. Do not think that you're going to take everything I do and perfectly is going to match your application, because this is more how do you say, more different than regular Excel. So if you can understand the principles, then you can adapt it to anything. And I don't care what you do. You can do nuclear engineering. You're going to find value that you can apply. I've been planning for a long time, but I really need now to get out a course. So I would recommend people to put their email address right here. Actually, yeah, just add your email address and the first name, and I'm not gonna pester you. I hate people who just send emails. I'll send you a few emails a year maybe, but I'm coming up with a course. I actually have the course. I just decided it was too complicated, so I'm slimming it down, make it a little bit more simple, not too long. The course was, I don't know, 20 hours, too long. So I'm gonna come up with a course, and if you leave me your email and the name, I will send you a notification. The course will be available not through Udemy, because there's some problems that I don't like. Udemy is great as a consumer if you consume, but as a producer is not so good. So the course will come independent. I will launch it by myself on I believe a platform called Podia. So Podia, and I will show you how to approach wireframe, much more advanced, much more detailed that I showed you in this talk, but still not too complicated, but and also repetitive. So which means I repeat certain important aspects quite a few times so you learn it. So, and also in the course, I have the same task done in the old Excel and the new Excel, so you learn better. Also, I'm getting into both wireframe and sprite animation, and how to automate, how to make a game. You can look on my site. There is one. Let me just go there. Okay, here, Excel Unusual. You can click on blog. Okay, you see here, blog. And I show how to make this. Okay. Wait. Is it this one? No, I think. Come on. There was a little cat here. But anyway, so I'm building a little animation, a little game. Oh, this one. So you can. I show you how to use arrow keys and jump and attack with a sword, which is it shows you the principles of animation. So you can spend time and look through this. I simply don't have time to go through all this stuff, but I will have a course, yes, very soon. Leave me email and first name, okay, and I will put it in my list. Next question, Mike. Thank you.
So Charles, Victor, do you have any questions? I don't want it to be like only me speaking. And I know that's why I asked you guys to come in here, since you are also.
Okay. I don't know if I'm being heard.
Yes.
Okay. Can one of your calls be doing geometry with Microsoft Excel? I think that might be primary and would help us come to the same footing with you, because for now, what we are seeing, we're trying to gain first principles and understand what you're saying. But if you have a course on geometry with Microsoft Excel, I think it will be a great one.
Also, if you can, if you leave me your name, first name only, and email, can you be a little bit more precise? What kind of geometry? I'll give you an example. Let's say I'm an architect. I want to plot land or whatever, land plot or a house. Very basic, of course. Or be a little bit more precise, because geometry is large.
Okay.
And personally, my experience is, from what you learn in high school is the most important, not college. If you know well what you did in high school is enough. And what you need, what you learn in high school, really only a very small percentage. It's not 100%. It's like, if you can know well 1 or 2% of what you learn from high school, you can really move mountains. Okay.
Wow. That's amazing. I think I have to go get my high school books and.
Oh, no. If you take my class, I will tell you exactly. Go read about this. Even 1% may be too much. Most of the stuff, especially trigonometry, all those formulas, derivation, you don't need them. All these limits, you know, all this, how to say, I don't know how to say in English, we say shear, which is the chain, converging series, yes, converging series. You never need those. You need integration, but basic integration, not the tables, the formulas. They try to cram you. They gave you a bad grade. They made you not sleep at night. No, you just need integration of basic. Is much easier. You need, like I said, less than 1%. Geometry is the most important. Triangles, similarities, straight triangles. and you can build a world. Okay, so leave me the name and the email, and also a little comment what you would like to see. If you don't have a comment, it's okay. Just leave the name and the email.
Okay, so they have already, so I'll get them across to you, or if you two are able to get them instantly. But let me know.
If you can, okay. If you can make the roller coaster, that then once you finish, I did not include it in my course, but if some people make the suggestion, maybe I can make another course about roller coaster. If you know how to make that, that's it. You are, how do you say, a graduate, and you can do anything.
Wow, it's interesting. So Victor, do you want to say something? I know VBA is also your domain.
Not when you have George here. I mean, come on. Hello, can you hear me?
All I do is dig deeper. I have a shovel, a small shovel, maybe smaller than yours, but I keep digging in the same spot. You probably go to dig all the garden. I just dig one spot. That's the difference.
Okay, hello, Michael. Can you hear me? And then yes. George. Hi, George. And I mean, come on, this is amazing. Anyway, I've always been a fan of your site. My first degree is in engineering. So, but I'm a chemical engineer, but I work as a petroleum engineer. So
petroleum is amazing. For petroleum, there's no better. I don't have much, but there's no better application in Excel than petroleum. You can do flow. You can do
exactly reservoir simulations. Yes, it's really amazing. So I kind of follow, of course, a lot of the things you did, and I also believe a lot in first principles and the basics. I feel that those are the fundamental things. Then whatever you do with them is really just your creativity. So I just wanted to ask a question. So looking at your models, I mean, when we look at them on your site, they look very complex. But with this session with you, we kind of see that the building blocks are relatively simple. So I'm just trying to get maybe two questions in one. One, are your models, where are they skewed more towards? Are they more formulas than VBA? Or, I mean, like in building the models, do you do more on the spreadsheet side or on the developer end for some of the examples you've shown? And then the second one is just maybe say, okay, in most of your models, what maybe method do you use the most in most of your models? Is it do events? Is it loops? Is it application.onTime? What seems like the key thing that repeats itself in most of the models you build? So those are my two questions. Yeah.
Good. I'm going to start with the second one because I don't want to forget. I use mainly loops, and so loops, and you don't need, you can pick up, say, for loop, okay? And for loop, or loop for until, do loop.
Do until, yeah.
Either one, you can adapt it. For it is a little bit more
restrictive.
But my blocks, I develop a few blocks like the start stop, and then the main animation loop that counts up, and I use only those all the time. You don't need, you just make two blocks, two bricks, and use them all the time. Most of my models until 2018 in June, when some people asked me to help them with a project, I used mainly cell formulas, VBA extremely limited. I use VBA to run spin buttons, and also I use VBA when I have to handle chart, like resize a chart, or But after 2018, these people asked me, said, you cannot use cell formula. I mean, you can use a few, but you have to use VBA. So in 2019, I start doing heavy VBA. I mean, if this can be called heavy, it's not really heavy, but until then I was barely touching VBA. Mistakenly, I thought cell formulas are always much faster than VBA, which is not true. If you do calculations in VBA, like tables and large, is fast. What is slow is when you update the sheet. So you have VBA paste in a table. So let's say you have a table to calculate 100 by 5 or something. If you do a calculation in VBA, fill the first row and then do another one, fill the second, that's very slow. But if you do the whole thing quickly and copy and paste the whole table, that's fast. I don't see an advantage anymore, as I used to at the beginning, using cell formulas. VBA, what is nice about VBA is just programming, so it's very easy to troubleshoot, whereas if you have a table full of formulas, complicated locations, and then when you come back, it takes more time. And now that I know I know the fact that the time is not taken by the calculation in the VBA, it's taken by interaction between VBA and worksheet.
Excel, yeah.
I use mainly VBA. So for about 2.5 years, I've been using mainly VBA. You can use it only with cell formulas, with just a start-stop macro. But so I would say at the beginning, use cell formulas, because it will give you a very solid basis and good two-dimensional understanding of the model. When you become more expert, like in your case, you're already there. But if you're a kid, you're a retired guy who never dealt with Excel, start with cell formulas. Don't worry about VBA. Use just a start-stop macro or a counter. You know, this clock macro that 1, 2, 3, 4, 5, 6 that increases a number, increments a number in a cell, and use everything else cell formulas. But if you're already a VBA user, use mainly VBA. Okay.
Thank you so much. That's an excellent response. Thank you. I really appreciate it.
Okay. So checking if there are any new. Okay. So what has happened is a lot of people have showed interest in your course. So George, you have to do the course. So
sure.
You already have it was showing interest.
I give you a time frame. Okay, a time deadline. Okay, by the end of March, I will have a course. Okay.
Great.
I have it. I just need to clean it and make it. And any suggestion, I will take it in consideration. So, okay.
Okay. Great. So it's been a very good play. It's been a pleasure having you. I don't know who else. Let me just check the people in the audience and see who else I need to call up to speak.
And when you guys make a break, I want to start another model, do another demo. Okay, but continue. Let's continue with 5 more questions or 3 more questions.
Okay. Let me check those in the audience. Most of the Charles, I don't know if you have anything, but I noticed you've been writing them in the chat box. Is there anything you want to say? Could be comments, could be question.
Yeah, I wanted to clear on my previous question. When I saw some of your work, I am somebody who loves geography. I was forced to read geography, but I didn't do it because I felt there was no money in geography. But one thing I liked in geography was diagrams. I saw that I could explain the geography in diagrams. A simple one is if I want to explain to my 10-year-old son how the Earth revolves around the sun. You see, I find it that it's something that I could apply these principles to. You see, so that's why I was talking about maybe a course in geometry with Excel that can help me to see, okay, these are what I can put together to come up with something like that, to make some things that I can use to illustrate, especially in teachings.
Can I start? Can I answer?
Please. Yes, please.
Okay. because your voice, I wasn't sure you were done. Okay, so there are a couple of models, maybe more than a couple. One is called, I don't know if you ran through my blog, one is called Day and Night over the Atlantic, and the other one is Day and Night across America, something like this. You can download. Let me show you how to get there. Okay, so say Excel animation. No. Say America. Okay, you see this? So you can open.
Yes.
You can download. Did you download it?
No, not yet.
So I downloaded it. Look, but the thing about this is I don't know if I tested in the new Excel. Let me see. No. And then there is another one here. City lights over North America. This may be a little bit better. About planetary work. So what you say, how this day and night comes around. Okay, check this out.
Wow, impressive. Wow, I like this.
So what I do is I went online and I typed satellite images of the Earth, and I found there's a fellow, he may be a physicist or something, he stores from a certain satellite. If you read the comments, so just go on the site and find these posts, type day, night, or America, or Atlantic, whatever. You see these are the posts. One is called City Lights in North America video, and the other one is City, let's say that day. The other is called Day and Night over the Atlantic, okay? So this is better because, let me see. Yeah. So, and it shows the time. So I take these images, let's say spaced, I forgot, maybe 10 minutes apart. And I put them on a chart, make sure they are all the same size. But the really cool stuff that you can really develop and learn much more, this is just basic, pretty dumb animation, is planetary motion. So planetary motion that I use is based on dynamic principle. What dynamic doesn't, in my case, mean dynamic like static and then no. There's two parts of mechanics, of mechanical physics. One is kinematics, which refers to only speeds and coordinates, acceleration. It doesn't refer to causes of motion, like forces. So if you watch, say, a boxing game, okay, let's say between Mike Tyson and Joshua.
Yeah.
You can watch on TV, you don't worry about forces. You just see the speed of the fist, you see the angle, you know, the acceleration. That's called kinematics. And then there's dynamics. You don't worry much about it. You know that Joshua can push 100 kilograms in a fist, whereas Mike Tyson maybe 120. You know that Joshua maybe can move the body faster, but Mike Tyson can move it slower, but maybe more stronger. So you all worry about forces. And the forces, using second law, which is force is equal to mass times acceleration. From forces, you can find acceleration. And through a very basic operation called integration, you can find speed from acceleration, because acceleration is the derivative of speed, and speed is the integral of acceleration. And from From speed, you can integrate and find coordinates. So that's what I use mostly on the site. But in your case, geography, you don't worry too much about that. You can, of course, study this and do this essentially wizardry of dynamics using forces, find out coordinates of the bodies. In your case, you care about kinematics, which means speeds, coordinates. You don't worry about forces. So it all becomes a matter of having tables and tables, long tables of coordinates at various times and displaying those coordinates in succession, first, second, third on a chart. And then again, yeah, for the kid, he needs to know why the moon looks like a crescent and then looks like a full moon. So here we can work out something with geometry to show why when the sun and the earth are in certain positions, the moon looks like this or like that.
Wow.
Also, you can make a lot of, you know, modeling about orders of magnitude. See, this is very important. The sun is at 8 minutes of light speed. So the light takes 8 minutes to come. So it's good to use Excel together with your kid or whatever you want to teach somebody to go into orders of magnitude to see how big the sizes are. Sizes the planets of sun and stars, how far they are. This is very, very important. And here you don't care about dynamics. You don't need to plot anything. I do have on my YouTube channel, if you open any of the videos and click on YouTube, go to my channel. There is one that I created, a little planetary system and like a constellation. You go into like a galaxy kind of, many stars. So you can navigate through the stars using basic animation. Actually,
Hello? Okay, I was.
Yeah. Go ahead.
Okay, let me. It's like you're sharing something on the screen. So let me quickly bring your screen back up. Yes. Awesome.
Okay.
Whoa. Wow. This is something else. Wow.
This is a model. Let me make a little parenthesis here. This is a model I made in 2010 and 2011. Wow. It's all based on dynamics and the real physics. Okay, so you can have this plane running, and
Wow.
And you can change, how do you say, relative to engineering, you can change various parameters as the plane flies, such as the length of the fuselage, okay? And see the effect. This is good for engineering, this kind of approach. If you make the fuselage very slow, I mean the length of the body, oops, what happened here is it's called loss of convergence. When you fly commercially, where is the length of the fuselage? Okay, here. They always, if the plane is not full, if the plane is, say, only a quarter of the passengers are in, the stewardess, the flight attendant comes and say, can you guys come in the front? Why? Because I explained this in my blog. This is a little bit more evolved, but if the center of gravity in a plane is too much in the back, the plane becomes unstable. So if, let's say, there is a plane hijacking and the terrorists put the people in the back, so nobody's in the front. The plane will crash. The pilot would not be able to keep the plane stable. So if you use this model, you can prove that, and I talk about this in my blog. But I'm saying you can run this model, and as you run it, while you run it, you can change various parameters, such as let's say the height of the wing. You see, but again, I'm in an unstable situation. Or you can use this. You see, this is a virtual joystick. Okay. If I push it forward, you see the angles change, and you can do various things.
Wow.
If you go back and forth, you see the red dot, that's the center of gravity.
Okay.
And this is done long ago when I was using very little VBA. All the formulas are here again.
Oh.
So what I have here is I took a little program called XFLR5. It's essentially a French repackaging of a program built by a MIT professor, who you can put a wing profile, and these wing profiles are usually designed by aerodynamics engineers, and based on the various speeds, you can find out the forces and the momenta that act on this wing. And I took this data, I simulated by hand several situations for various angles, for various speeds. I put them in Excel as many tables. Look, I'm gonna zoom out. So there's I don't know, 5 to 10 tables here. And I use something called interpolation. So if you plot anything in Excel, you can go and say add trend line. And when you say you choose a certain order is a polynomial, I think I use order 4, and then it created a simple formulas for each of these tables. So rather than have many points, I have a formulas. And another thing is between points. So let's say I measured certain parameters for angle 1 and for angle 5 degrees. Between them, these formulas can fill out, interpolate the data. And then using, like I said, these Newton equations, 3 equations, I was able to model this airplane. Okay, I'm done. Please come with the next question.
Okay, so at this juncture, I think we would have to, there's another session coming up. So we'll have to start thanking you. And so I think we might want to bring you on another session if you are willing to come. So will you be able to maybe, I don't know if it might not be this, I don't know your availability.
Yes. So let's make another session for questions, okay? So prepare questions, and if there's something that you want me to talk at the beginning,
okay,
you can communicate this to Mike, and I will prepare something for the beginning, and then just questions. I'm looking here. Give me just 1 minute, okay? If I see something.
Okay.
Yeah. So anytime I am even within a week, anything more than a week, I'm willing to do it. Okay. But I say I need a week because Mike will come with some feedbacks and he might tell me something to prepare.
Okay. So I'll get across to everyone and see if there's any particular thing they want you to talk more about. So I'll give you the feedback, and also, but it would be really nice, I want to be able to also announce to them that, oh, your course is also ready, so that, so just see us as motivations to you, because there are many people, I'm sure, who also like me I've always been looking at your site and be like, this is just awesome. I wish I can be able to do something like this. And then to find out that you're creating a course already, I can't wait for you to tell me the course is ready. So
I have the course, but it's too complicated. I need to slim down the course.
Okay, okay. So, we want to say a very big thank you for accepting. And I didn't confess fully to the house before, but actually, it should have been on the 30th of January. Then I made a mistake on my part. Remember, it was supposed to be 30th of January. Then there was a mistake on my part. But yet you are understanding. You didn't, take offense, and you came back to speak the session on a very short notice. I'm so very grateful for that. I don't think I will ever forget that, because I was very, very sad that we had agreed a date, and then I made mistake and allocated the date and kind of got things mixed up. But I'm very grateful, and I'm sure people are also very, very grateful for your time and your patience in explaining and helping us to really understand that there is a mindset that we need to have above just trying to memorize syntax, learning tools. I'm noting that down. I'm going to start applying them. So I want to say a very big thank you. So that's
memorizing syntax. Memorizing syntax is for young people. Okay, so if you're young, you have a lot of memory. When you're old, don't waste your time.
Yes, yes. So thanks a lot. I know we didn't let you sleep very well overnight. So I guess, I don't know if you want to take another round of nap just to refresh again, but thank you very much.
Sure, you're welcome. And program me anytime. Give some time, because usually people talk to other people. Maybe we can get more. And if some people come in advance, let's say bring 20 questions in advance, awesome. So I can read them before I even, a few days before I start this, so I kind of have an idea, okay?
Great, great. Thanks a lot. So to all our participants, thank you too for joining. And so at this stage, we are bringing the session to an end. So I want to wish everybody a happy new week ahead, happy Sunday, happy start of the week. And George, once again, very big thank you. We are very, very grateful. Thank you very, very much. Have a nice Sunday. Bye.
Bye. Take care. Have a good one.